Okay, so I'm going to do one more example of division to give you a good idea of what we were talking about. I went pretty fast um, through it. So when we are talking about division, we want to multiply by the conjugate of the bottom. So when I look at this, I'm going to multiply by the conjugate 3 plus 2y. Whatever I do on the bottom, I've got to do on the top. Now this one's a little bit more in depth because the top and the bottom are complex. So on the bottom, 3 times 3. 3 times positive 2i, negative 2i times 3, negative 2i times positive 2i. I get negative 4. Remember when I take an I times an I squared. So we're still working with the bottom. Multiplying by the conjugate, those middles cross out. We see I squared. It's negative 1. It goes away, the sign in front of it changes. So that bottom is 9 plus 4, 13. On the top, 5 times 3, 5 times 2i, 2i times 3, 2i times 2i is positive 4i squared. Now you don't have the conjugate on the top, so don't expect them to cancel out. So I squared goes away, change that sign, put together like terms. 15 minus 4 is 11. 10i plus 6i is 16i. That would be done. So also, we did not talk about plotting complex numbers in fourth period. There is when we, if you are asked to plot complex numbers, there is a complex plane. The real axis is the x-axis. The imaginary axis is the y-axis. And plot it just like ordered pairs. So my real part is 3, positive 3. I go right 3. My imaginary part is negative 2. That's up and down. It's negative, down 2. That is 3 minus 2i. Negative 2 plus 4i. I'm going to go real left since it's negative. Imaginary up since it's positive. Negative 2 plus 4i. Done. 3i. Real part is 0, so don't go right or left. The imaginary part is positive. Go up. 3i. Don't make that any harder than what it is. Last thing, you are asked the absolute value of a complex number. If I ask you the absolute value of a complex number, think absolute value is distance from 0. So in the coordinate plane, it's going to be the distance between that number, that point, and the origin. So I just sort of drew a picture. You plot it and then think. You're really using Pythagorean theorem because you want the hypotenuse, which is the diagonal distance from 0. So I'm going to erase this and sort of show negative 4 plus 3i. This means distance. So plot it. I just show the picture to help. Negative 4 plus 3i would be there. How far away is that point from the origin? Well, think. That's 4. That's 3. Doesn't matter that it's negative. I want this. a squared plus b squared equals c squared. That's 25. Square root, that's 5. Now, if it does not come out nicely, you reduce your radical. So if I just draw a generic picture here, this is the absolute value of 2 minus 6i. Right 2, down 6. How far away is that from the origin? That's 2, that's 6. There's your right angle. 2 squared plus 6 squared equals c squared. Well, that gives me 40. Square root both sides. It's radical 40. I don't want 6 point blah, 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 blah. I want, that is radical 4 times radical 10. That is 2 radical 10. So hopefully that helps. We will see you Tuesday.